Hello everyone, myself Tanmay Dattatreya More. My group member is Dhanraj Gaikwad, and our topic is fuzzy logic in image processing and pattern recognition. So one of the most common applications of fuzzy logic is pattern recognition, which is majorly used in image processing. So a pattern is a physical or abstract structure of objects. It is determined by a certain set of attributes which are known as features. What is pattern? A pattern is a recognizable arrangement of objects, elements, or data. It can be physical, example, the shape of leaves, facial features, or abstraction, example, trends in data, behavior in AI. How is pattern determined? Features are specific attributes or characteristics that help identify a pattern. These features can be color, shape, texture, intensity, size, or any measurable property. Example in image processing, in facial recognition, patterns are identified based on features like eye distance, nose shape, and facial contours. In medical imaging, patterns in X-rays or MRIs help detect diseases based on features like tissue density and irregular growths. Introduction to fuzzy logic. What is fuzzy logic? Handling uncertainty and imprecision. Unlike where something is true or false, fuzzy logic allows a partial membership. So it works with degree of truth 0 to 1. Fuzzy logic assigns a value between 0 to 1. So 0 is completely false and 1 is completely true. Why it matters? Useful for complex systems that need human-like reasoning. Many real-world problems don't have clear-cut answers. But fuzzy logic is used in AI, robotics, and image processing, where decision needs to be more flexible and human-like. Role of fuzzy set in image processing. First is image enhancement. In that, contrast adjustment makes a difference in brightness clearer, so details stand out. And second is noise reduction. It removes the unwanted part, so the image is more clearer. So example we have seen is tumor. In medical imaging, enhancing MRIs or X-rays, it helps the doctor to see the tumor clearer. So second is segmentation. Divides an image into regions such as color, intensity, or texture. So example is segmentation can isolate the tumor from the surrounding tissues. Third is feature extraction, finding important patterns. So we will see the example of tumor. In tumor, it can find the shape, size of or texture of the tumor. Fuzzy set and membership function. In that, first is fuzzy set, means elements with partial membership. So unlike classical set, where an element either belongs or does not belong to a set, fuzzy sets allow partial membership. This means an element can belong to a set to some degree rather than just a strict yes or no. So it means that we have seen classical sets where either an element belongs to a set or does not belong. But in a fuzzy set, we can say that element belong to some degree in that set. Now, what is membership function? Defines the degree of belonging. So, what is membership function? It assigns a value between 0 to 1 to indicate the degree of belonging of an element of a fuzzy set. So, a value of 0 means not a member and 1 means fully a member. And value between 0 and 1 indicates partial membership. So what it means, we have given two values 0 and 1, and value can be belong between this degree of belonging from 0 to 1. So we will see the example of membership functions. A pixel in an image can be partially dark and partially bright at the same time rather than being strictly dark or bright. This is different from classical logic where a pixel would be classified as either dark or bright with no in-between state. So we have seen in classical logic that image pixel should be either dark or either bright. But in membership function, pixel can be partially dark or partially bright. So now we will see the graph. In this graph, a solid curve shows the membership function with showing the gradual transition, and dotted line shows the classical set where the transition is sharp and binary, which shows either the element is in or out of the set. I would like to summarize all. Fuzzy logic and pattern recognition plays a crucial role in handling uncertainty, imprecision, and complex decision making. Unlike traditional binary logic, fuzzy logic allows for partial truths, making it usable in image processing, AI, and real-world decision making.
So now will continue with pattern recognition as per my told with image processing. So in pattern recognition, basically what is pattern? Pattern is a structure of object which will contain the set of attributes we are going to as them features. So here we see the fuzzy logic architecture, in which basically we have fuzzifier, defuzzifier, rule base and interface engine. Then in fuzzifier, CRISPR values or input values are converted into the fuzzy values, which will be given to the interface engine. Basically, rule base works as set of rules which will be applied to the fuzzy values for processing into the interface engine. Then interface engine is interface engine is useful for processing the CRISPR values or input values which are given by the rule base, and rules from the rule base are applied to the input values, and then it will process the input values and converts the input values into CRISPR input values as output, and it is given to the defuzzifier. Basically, defuzzifier is used for converting the output values which are given by the interface engine to convert back into the CRISPR values as it will be given as the final output. So next we will see the challenges and advantages in fuzzy logic. First advantage is handles noisy and uncertainty. That is, fuzzy logic allows the environment, that is when there is a noisy condition in an environment, fuzzy logic allows to capture that noise, and the conditions which are present on that the pattern is allocated to the image or the available condition. So the next one is mimics and human reasoning, in which the fuzzy logic allows us to generate the output as humanized output. That is, it will generate the output as it is generated by the human, or it will generate the output as it is thinked by the human. And the next advantage is adapted to dynamic environments. That is, fuzzy logic allows us to it will adapt in any condition or changing input condition. That is real-time example as medical diagnosis or image processing, etc. Then we will see the challenges in fuzzy logic. First one challenge is designing membership function is quite difficult. That is, membership function is designing is quite difficult. We will face many problems while designing the membership function. Next one is can be computationally expensive. That is, it will be very expensive for hiring the people. Then we will move to conclusion. In conclusion, we will see that the fuzzy logic is very useful when the data is incomplete or imprecise data is present. Fuzzy logic allows us to generate more type of output when data is incomplete. That is powerful for handling the imprecise or complex data. When data is very complex or incomplete data, it will generate the output as more grateful as more. Then next one is future trends. Combining fuzzy logic with AI and deep learning is the future trend which will be upcoming in next years. And for example, smart surveillance system, advanced medical diagnostic. In conclusion, we will say that the fuzzy logic is very useful when data is incomplete or imprecise. It will generate the more useful data while data is incomplete or it is complex data. In conclusion, we will say that it is very useful in AI and machine learning, then cars, their image processing, pattern recognition, and it will be very useful when the data is incomplete or imprecise, or when the data is complex. We will apply or use it when the data is incomplete.